In this transmission network model example, contingency analysis is demonstrated. In this example, study case contingency analysis should be activated, together with scenario-based scenario. Contingency analysis is a load flow study of the network in the event of unplanned outage of one or more elements. For example, a line fault. Contingencies can only be executed if there is a valid solution to the base case, so let us first execute a load flow to check. In order to run contingencies, the relevant toolbar must first be selected. The contingency definition button here can be used to define standard fault cases, for example, all lines. In this project, fault cases have been defined for all lines and for all bus bars. Fault cases are stored in the fault folder of the operational library. It is also possible to create fault groups, which are groups of shortcuts to fault cases. Now we can set up the analysis which we want to carry out. On the contingency dialog box, Basic Options tab, the parameters for the load flow can first be adjusted if required. These same settings are also used by default for the contingencies. Limits can be set in order to manage the amount of data recorded. Contingencies are selected using the Add Cases Groups button. We will select the group of line faults. Now the analysis can be run. Look at the grid graphic, which has been colored according to high and low voltage and loading. Elements on the graphic are each colored according to the highest loading or largest voltage violation for that element, taking all contingencies into account. However, the results displayed are those of the base case. Standard reporting scripts are available via this button. There is a range of different reports. Here we will select just the loading violations and execute. To see the relevant elements in the network, the mark-in graphic function can be used on overloaded components or contingency cases from the report. It is also possible to execute an individual case to look at it in more detail. If a case is executed individually, the post-fault results can then be seen in a filter or on a graphic. Customized fault cases can also be defined. A simple way to do this is from a graphic. As an example, we can create a double circuit fault on these circuits, which form the interconnection between the northwest and the southwest. The name can be changed if required. This can then be selected to run in our contingency analysis. We can now see the resulting overload in the report.